Computer viruses have caused over $100 billion in damages since they first appeared in the 1980s. But what exactly are these digital pathogens, and how do they actually work? A computer virus is a type of malicious software that, much like its biological namesake, attaches itself to a host and replicates. The key characteristic that defines a true computer virus is its ability to insert its code into other programs or files, effectively infecting them. The life cycle of a computer virus begins with creation. Programmers with malicious intent write code specifically designed to exploit vulnerabilities in computer systems. This code is then packaged in a way that allows it to spread and execute its payload. Infection occurs when the virus code enters a computer system. This typically happens through human action such as opening infected email attachments, downloading compromised software, or inserting infected external storage devices. Once the initial infection occurs, the virus remains dormant until its host program is executed. When the infected program runs, the virus activates and begins its replication phase. It searches for other suitable files or programs to infect, copying its code into them. This self-replication is what makes viruses particularly dangerous, as a single infection can quickly spread throughout an entire system. Viruses employ various techniques to avoid detection. Some use encryption to hide their code, while others modify their structure with each new infection, creating what are known as polymorphic viruses. More sophisticated variants, called metamorphic viruses, completely rewrite their code with each replication while maintaining the same functionality. There are numerous types of computer viruses, each with distinct behaviors. Boot sector viruses infect the master boot record of storage devices, activating when a system starts up. File infectors attach themselves to executable files, while macro viruses exploit the macro programming capabilities in applications like word processors and spreadsheets. Particularly dangerous are multipartite viruses that can infect both boot sectors and files, creating multiple infection vectors. Stealth viruses actively hide from antivirus software by intercepting its requests to the operating system and returning clean information. The payload of a virus represents its actual purpose beyond mere replication. Some payloads are relatively benign, perhaps displaying a message or playing a sound. Others are destructive, corrupting or deleting files, encrypting data for ransom, or creating backdoors that allow unauthorized access to the system. Modern viruses often establish persistence mechanisms to ensure they remain on a system even after reboots or basic cleanup attempts. They might modify system registry entries, create scheduled tasks, or install themselves as services that automatically start with the operating system. Viruses can spread beyond a single computer through network connections, shared storage, or even through software distribution channels if a legitimate program becomes infected before distribution. The internet has dramatically increased the potential spread rate of viruses, allowing them to reach millions of computers in remarkably short time frames. Detection of viruses typically relies on signature-based methods, where antivirus software compares files against a database of known virus code patterns. More advanced detection uses heuristic analysis to identify suspicious behaviors that might indicate the presence of previously unknown viruses. Protection against viruses requires a multi-layered approach. Regular software updates patch vulnerabilities that viruses might exploit. Antivirus software provides real-time monitoring and scanning capabilities. User education remains crucial, as many infections result from social engineering rather than technical exploits. Computer viruses represent a fascinating intersection of programming skill and malicious intent. Understanding how they work not only helps in protection but also provides insight into the complex relationship between code, human behavior, and system security. As our digital infrastructure continues to expand, the evolution of both viruses and our defenses against them remains an ongoing technological arms race.